Good afternoon. I'm the last guy between you and the bar. So was that celebrating that the bar is soon, or that I'm in your way? All right, so I will be fast. My name is Glenn Wiebe. I'm a solution architect with GridGain. And somewhere around the halls, you may have seen my counterpart on the sales side, Chris Cook, who's on the Director of Public Sector in the Financial Services. So if you're interested in getting more information, I suggest reaching out to Chris for that. Let's see if I can actually get my mouse to work here. Nope. Okay, so can you guys hear me okay, or do I have to hold this closer? Thank you. So I'm going to summarize the current state of IT modernization in the government sector and how in-memory computing can provide some real value in that space. I'm going to focus on 4 use cases that I think we're seeing a lot there, and because I think you guys are somewhat technical, at least that's what I was told. This is Apache after all. I thought I would take some time to go into the actual product hands-on. So you can cheer for that if you want. Hands-on code, yeah. Okay. So in terms of the challenges in the IT modernization, especially in the government sector, we're seeing a lot of these kinds of things happening. So volume is exploding. Everyone knows that. Velocity is accelerating. And where's latency going? Expectations for latency are near real time or real time, right? The users are expecting more applications, more clicks, more data, more frequently, right? So that's putting a lot of stress on our applications, but it's putting a lot of stress on our databases, right? It's also putting stresses on our development organizations. Who here is part of a development team? So you guys are stressed out. I'm surprised you're actually here. Like, why aren't you back at home working or at the office working? Okay. So to handle that greater volume, you know, the greater velocity, the greater volume, and the lower latency, we need to have horizontal scalability. I think Hadoop was right in that regard, right? Splitting up the data, splitting up the environment to create a distributed compute platform. That's clearly the right answer. Greater I/O speed is important. Yes, it's great that the hard disks, the spinning disks are getting faster, going to SSDs, but memory is still faster and will continue to be faster as well. And then I think you need data and processing affinity, right? So you can't be fast enough to bring all the data to one person, one agent, one algorithm to get the query back effectively. You need to split the data up and bring the compute to there. That's pretty much the definition of in-memory computing for us, but it's memory-centric. Okay? We are an Apache project, so Apache Ignite is one of the top 5 projects out there. We're getting, right now, last year we did 2 million downloads, and we're one of the top 5 projects on those 3 metrics. Okay, so we appreciate Apache supporting us through that. Now, with in-memory computing, we're seeing a whole ton of use cases that range from the tactical, make things faster at the lowest level sort of complexity, all the way up to the strategic, unlocking more data. Let me have more applications, new, unique applications with lower latency, streaming, complex event processing. All these are different types of use cases that we're seeing for us. Today I want to focus in on 4 specific use cases that hopefully you guys are seeing in the government sector. One is the making databases faster, moving to real-time, event-based streaming and processing and analytics, low latency Hadoop acceleration, and machine learning and deep learning. Okay. Any questions before I jump in? You guys are okay? I've set the stage all right? All right. Okay, so on, make sure my screen is showing what my screen is showing. Good. So many of you have heard of caching solutions out there. So we're talking today about an in-memory data grid. That's one of our use cases. So an in-memory data grid is more than just a cache, that, like a Redis type of world, right? It adds the SQL language, SQL semantics, so that your existing applications that use that very important language can continue to use those, but do it very fast in a caching in-memory perspective. By caching the data and making it SQL available, you can offload a lot of the hard work that your databases are doing and make them still relevant. So if you want to bring in a new application, new web application, and bring in new users, that's going to double the load. Instead of having your database now crawl on its knees and or have to go back to Oracle and say, well, okay, yeah, we'll give you another $1 million to get to the next level of whatever. Instead of doing that, you can inject a database, an in-memory database, to do that kind of stuff. And then with the ACID level transaction support, we can keep that data in sync. So it's not just a one-way feed to a cache, but you can, your web applications can actually write back to the cache, and those updates to the cache will be reflected in an atomic transactional basis to the underlying database. So you keep things in sync, which reduces the cost of building those kinds of applications. Now, above just a data grid, there's the in-memory database. And for us, what that means is we can actually be your database of record. This is what we call Ignite Persistence. And Ignite Persistence is a disk-backed durable storage. So yes, we're a memory-first solution. Processing takes place in memory. But if you only have a terabyte of storage in memory, and your data is 2 terabytes, we can still support that solution with an in-memory approach. Your data that is being queried quickly or frequently, will be in hot memory, and data that isn't as frequent but does still need to be queried can be pulled off the disk. Okay. So that's Ignite Persistence. And you can have any size of this solution. So you can be 100% in memory, just disk-backed, or you can have a small amount of memory and have a huge amount of disk storage, and we'll do it dynamically for you. Because the solution can be very small memory, if you think about that, that's the same thing as what happens when you restart a cluster. So if your cluster goes down, you don't have to wait 2 hours to reload your cache. Because in fact, if it's in disk, we can still query it. So you bring the cluster back up, start hitting with queries, we'll give you your data from disk. And then that'll rehydrate it into memory. More queries, more rehydration, and then eventually everything is rehydrated. Right? So there's some real performance benefits for having disk-backed, persistent, and durable storage in a memory cache. So an example of this, an unnamed, I was told I can't actually say their name, an unnamed federal agency was struggling to deliver a new web application off of their Oracle database. And this was slow. It was new usage. It was slowing down the data. As you guys know, for many web applications, it tends to be a lot of small hits. More connections, smaller, not a lot of data necessarily, but lots of hits, which can really slow things down. So by inserting Ignite in between Oracle and the web application, they could instantaneously generate fast response in the web application and offload that extra performance hit off of Oracle without having to build up by another or higher end Oracle system. And to meet the volume, they can just linearly scale the number of nodes that they need. That's it for the first use case. Any questions about the database acceleration?
So there's certain websites, like very recently Cox Internet, which is what my provider is, they went down. So I went to this site to check service or check outages,
Right.
And it was performing very slowly. And that was an indicator to me, oh, it's not just my router. Everybody is hitting this whatever health check type of website because it's performing slowly.
Sure.
I mean, is there going to be a case where are we at the point? I guess what I'm asking is, I feel like a lot of the websites are performing at a very predictable rate that's acceptable to me. So when I see the slowdown, I mean, if every website got accelerated, where does my indicator come from for when a website's getting hammered?
Well, it's a tough question, right? And you do need to know the topology of your data. And the idea here is that we're going to accelerate you, and some people need techniques to accelerate. And we're going to give you techniques for accelerating that don't require you to scale up. Right? That's the key difference between a distributed cache, a cluster, that can scale out horizontally, just add more nodes, and whether that adding more nodes is just in your data center, or whether adding more nodes is adding dynamically more EC2 cluster nodes, that gives you instant on capability. Whereas in past, you would have said, oh, Oracle or Teradata, I need to go to this big a machine to support that load. Right? So it's less about why it's performing slowly and giving you the tools to be able to do it. The topology is always going to be a challenge, right, as to what the real issue is. So I'm sorry, I don't know if I could answer that question directly.
You answered it indirectly, because basically that's the wrong use case. They're not your target audience for this type of acceleration.
Sure, right. Anyone else? Okay. Oh, sorry, over here.
Yeah. For this use case where you're accelerating the database, is that at the JDBC driver level, or is that at the wire level? I have a use case where I have applications in Java and Python accessing the database, and I see a bottleneck coming in the future.
Absolutely. That's a great question, and the answer is yes. Yeah, because essentially what we're doing is providing an infrastructure behind the scenes that is fast and accelerated. And we're giving you any number of APIs to support that. Now, what I will say, a more interesting conversation is, for any individual API, are there things, is there a secret sauce to go into the API, into the driver, to take advantage of this distributed nature? So that's what we do behind the scenes for you, and we have what are called thick and thin clients. And the thick client is the moving some knowledge about what the cache distribution is into the client so that the client can be smarter. Okay, so we have that today, that logic, that little nugget of knowledge is part of our server. Obviously the server needs to know how to distribute load across where the data is. We have smart clients that have that added in. So if you use an Ignite product, you want to see, is there a thin client or a thick client? And I'm not saying that a thin client is bad, I'm just saying that behind every thin client, there is a piece of smart that has to exist somewhere. So in the case of a thin JDBC driver, we have two by the way. The thin JDBC driver has to be proxied to a node that has the smarts and distribute the query. Python is a thin one as well. There's some machine learning algorithms, however, like in Spark, that are smart, and those know how to distribute the load, and so they don't need this extra hop. Does that answer your question? Okay. I'm giving a demo, but I thought I would also just walk through quickly what is happening in the database acceleration scenario and how our tools are involved. So if you look here, this part here, the black and red is part of our cluster. And we have data sources on the left, and we have app dev tools above. So the Ignite web console can introspect. You probably can't see this, but that's called introspect. That's number 1 there in yellow. introspect your data source, existing data source. So in the previous scenario, I would see my Oracle system, all the Oracle tables and views, and I would be able to import those and generate the cluster definition for that. I would get all of the SQL semantics, what the data types are, the columns, schema, so forth. I would create an object model in Java for it, so for those people that want to deal with it on an object basis, I have all of that. And I generate and deploy my cluster from Maven. There's a number of, I can't remember, try to remember, not Maven, but what's the other one, Gradle? Yeah, Gradle build as well. Docker, a whole bunch of deployment options. Then I can load my data one time, or through the other APIs, command line, or through streamers, connectors, I can bring data in on an ongoing basis. And then most importantly, now that I have my cluster that has been imported, deployed, and running, I can now interact with it through any number of APIs, and I'll show you more APIs a little bit later, but some of them are listed there. So that's what happened. That's sort of the process for replicating a cache. What does it say over there? 5 minutes?
So basically you have 20 minutes to speak, right? Then 5 minutes questions, 5 minutes so like.
But I have 45 minutes. I thought. Okay. All right. Well, then I'll move on very quickly. Then, sorry. I thought I had 45 minutes. Okay. My apologies if I'm wrong here. Okay. Next use case is real-time and streaming analytics. So key aspects of the real-time and streaming analytics solution. Obviously, key part of that is having streaming ingestion. Right? So we have support for most of the key streaming ingestion options. JMS, MQTT, Kafka, Spark streaming, etc. Okay. Another important part of streaming analytics is to have continuous queries. The ability to register your queries against the cache or against tables, and when anything changes, your query is updated and you get events, and you can apply the analytics to that event. Okay. And then on the Spark side, key thing here is Spark. To enable Spark support, we've extended the capability of what RDD and data frames can provide, so that the data frames can now take advantage of the entire cluster. The data doesn't have to be on a per node basis. You have access to everything in the platform. Also, state can be preserved, both between jobs as well as between workers. And you can create, with a standalone option, you can create a Spark application that has a lifecycle extending beyond just a normal Spark job, worker, or application. American Express is an example of one of these scenarios. They did, as many customers do, it's a progression. They started with database acceleration for their mainframe data sources, and then they moved on to do streaming data from their DB2 platform and real-time processing on receipt of data coming in from DB2. Okay, Hadoop acceleration. In many ways, Hadoop, can you guys see that from the back? This is a test for you, Mike. That's kind of, this one here says leucine, by the way. No, you can't read that? Okay, my apologies. Okay. Oh, thank you. Okay. Was it all of the cookies I gave you last night? Yeah, okay. In many ways, Hadoop, HDFS, MapReduce, and the animal farm, that is, the Hadoop distributions today, very much like your database scenario, because many people putting data into the data lake are really looking to it as a data source to do analytics against. And we can speed that up by bringing data out of Hadoop, bringing and exposing it into a cluster in memory and very fast. But it has some unique occurrences as well. So this is where our ability to use Spark, support that, and to accelerate your queries when Hive is very slow, that's a real key differentiator for us. 2 minutes, wow, okay. Okay, so the last use case then is machine learning and deep learning. So everything we've been talking about is about speed and scale. So one of the big tasks for a data scientist is that process whereby they go get the data, a whole bunch of data wrangling, bring in the test data set, test it on their data set, build it, and deploy it. Well, when you have an exceptionally fast data source, there is no need to separate it out. You can go against the full data source because you get the speed. By performing data analysis, running your algorithms on the cluster, you can do it in real time on the real data. That's continuous learning. So as new data comes in, your algorithm just continues to grow that. So that's the whole continuous learning approach that we can do for you. Now, I think I have another slide here. So these algorithms on machine learning and with TensorFlow have been optimized for the fact that the cluster is spread out, that it is distributed and partitioned. So these algorithms know where your data exists. It knows how to split the data up, split the algorithm to send the algorithm to the appropriate node, run the split query there, join it back up, and get you your answer. So machine learning with algorithms that we've implemented, and the list is growing every day, can be super fast instead of having to bring all the data to one node. And we have another federal department that was standing up a data lake, and I keep hearing, oh, can you put something at the end of the data lake so I can query it? So that's very much what Ignite is doing for you, is enabling the data that's in the data lake to get the value out of that. Okay, I was going to do a demo, but in lieu of my 30 seconds I've got left, here's 2 screenshots. Here's Eclipse, and here's scikit-learn and Jupyter Notebooks. Okay, I have 5 minutes for questions, is that right? Okay, questions?
Can you elaborate a little bit more about the annex use case? Like just what I was listening, I was trying to figure it out.
And I was starting to run at that point.
Yeah, you're starting to run. So just a touch more about kind of what they were trying to do. So they were trying to do offline DB2 performance.
It was in their business-to-business exchange. So this is about clearing things for the business. Where was that? And it was taking them 4 days to, I don't know, I must have missed it. It was taking them 4 days to clear this stuff, right? So not that was only the processing time, but by accelerating the data out, bringing it out of MDS into Ignite, they could get it down from hours processing into minutes, right? So that they could settle these things in 1 day. Okay. Then their business logic was that if it's taking this long to clear this stuff, 4 days, then the vendors, our merchants, are getting antsy, and they'll move to the next vendor. Right? It's starting to be very competitive, right? MasterCard and Visa, all these kinds of things, right? So, I hate PayPal. I don't know why. How about TransferWise? Zoom now is online ones. Anyways, any other questions? My pleasure. So how much time do I have? When am I supposed to be finished?
You right about now, but you're good. You got time for questions.
Well, I asked questions. I got 2 questions, but she was suggesting that if no one's kicking me off the stage, I could actually do a demo.
Okay, go ahead.
That's the question. Can you do a demo? Oh, yes. So the answer to your question, we're still in question time.
I mean, I can do bunny foo-foo, but his demo is probably better than mine. Am I blocking the stage? Yeah, sorry.
I'm going to have to switch out of extended mode because I'll never see my mouse and go into duplicate.
Now, what is it they say? Never work with children, pets, or do a live demo?
Never do a live demo. This is what I've been told. And I've never done this before. Never done this before.
Could go wrong.
What could go wrong?
You're on camera.
And that's when the projector caught on fire.
That's when the projector. Could you please turn the projector on fire right now? Okay. So what I'm bringing up is the Ignite Web Console. And
Can you swing the microphone in? Yeah. Thank you.
I don't think you guys were expecting demos, were you? You're not set up for demos here, are you? Like I can barely get my hand in here. Okay, so let's say we want to import a database. You can, this is now reaching into the cluster and saying, hey cluster, I see that you've got these libraries available to you. Go to the local data source. Password 1 is my password, by the way, for all demo things. So if you break into my computer, password 1, capital P. Okay, so who wants, what kind of data do you want? AdventureWorks is the, the one from Microsoft. Instacart is a customer one. I'm getting some nods on Instacart. So we'll go into Instacart. We will pick all of them. And then we'll say yes. Let's pick those. And we can say, you know what? The products, I want those replicated. So what does that mean? So partitioned is, I've got a million rows. I've got 10 nodes. I'm going to put 100,000 on each of them. Replicated is, you have a small data set. Make them available everywhere so I don't need to move the data across partition nodes. Okay, so that's that. I say next. I want this to be in some kind of packaging namespace. So I'm going to pick Instacart, Instacat, something like that. Roadshow, just in case I've already have that namespace in there. Why would I have that? And I've now got a new imported cluster with my 8 things. I want to add I want to go into the, where to go? I want to go into departments and add a new index because I think we're going to be hitting the, the department string. I would really love that to have another kind of index. I want it to be a full text index so I can do Lucene search as well as just regular fast B-tree querying. I'm going to call it ASDF because that's my favorite name. I'm going to pick the department so I can now do that. It's writing my Spring configuration file. I hit save and then I hit save and download. I get my zip file, Roadshow cluster, and I unzip that. Don't look closely. Don't look closely. Don't look closely. I import my zip file that I've just downloaded. I import my Maven. And there is magically my project. And if you want to see it in Eclipse, that's what I do. If you want to do it in IntelliJ, you can. If you just want to go out over to here and say Maven build, that's all you have to do. Notice also that we deliver a Docker file with this. So if you've installed the Docker utilities on here, you can right-click and run as a Docker build. And then go into your Docker thing here and run it right from here. So that, if I had more time, that's what I was going to, and then I was going to go into my other part of my demo. After I showed that, I would go into Jupyter Labs and I would say in a matter of 8 lines of code, I can import the Ignite Pi library. I could create a new cache. And now with my new cache, when I go back to my Web console, I now have a new cache that is in the monitoring side. Dashboard. And then what did I call that cache? No, the last one just now in my Python, my cache. Okay, so that if I had 15 minutes, that would have been really much more in depth. Okay.
Could we get a hand for
Thank you guys. I even got a woohoo. I got a woohoo.
Very nice.